Okay, I think I should probably be good. If you're here last time, stream died out. So I'm just going to finish that example and then go on to another example. So back up here, I was going through this example of I forgot my things aren't set for the mouse. So this example of I went through this example of scoping and the different rules that I have in place. I still have to think about some things, but for the main part, we have procedures here. I have this procedure in this library, and I can use it down here. Yes, this line. And everything's fine. And if I instead do, say, I have this procedure variable. It's a variable of a procedure. You can see right here is the body of the procedure. Then it has a variable declaration back here, name. Then we get into the type. There's the type. And then of course I made this a constant because really all this is doing is being a procedure. It's not really doing anything else. It's just here to be a procedure. And then we can see down here that while it is there, it is a procedure variable, which means that you can't call it. You'll get an error. And then I was also discussing quickly that if I had this, like a random number generator here, that this shift variable would, I think I still have it down. No, I don't have it down here. I don't think I got to that part. This shift variable I would not be able to access from outside of this library. But I have procedures that right here that can access it. That can, set it and then return it, do other things with it, then I don't think I got to this part. Yeah, I don't think I got to this part of the stuff down here, because I was talking about the stuff up here. So I have this procedure, fubu, and it's of course from real to bool, as all of these are. And as you can see down here, like you'd expect, I can call it just fine. But phi b, this procedure variable that I have here declared within fubu, you actually can't call, and you get a compiler error, because of course that's a variable within a procedure. Just like all variables within procedures, you can't see them. But you can see that I have here fa ba, and that seems to be able to be seen and called. Now, where is fa ba? Well, fa ba is right here. Now, I need to make sure this syntax still works, because I've been changing delimiters on things, but basically it's a label. If you've programmed with a macro assembler, and I'm pretty sure C allows you to use labels as well for the goto statements. This it's the normal syntax for a label, but here this is specifically the label is specifically saying that the rest of this procedure, because this can only be inside of a procedure, the rest of this procedure, which of course would never be able to, you couldn't get here because it's a return right above it. The rest of this procedure down here is another procedure with the same signature, and that's why I can call it right here. And that's a procedure declared in a procedure. That's specifically what that is. Like I said, I still have to think about syntax, because at this point this syntax might not work with colon as a delimiter here. But I'll have to see. So intended uses of this, specifically, the thought is with this is that you can make a small procedure and then a bigger procedure that uses that procedure at the end of it. So you can have them, well, essentially, that would allow you to have this, the bottom procedure inlined in the bigger procedure, and also have them in a specific ordering in memory. And of course down here possibly to do specific things that you might sometimes you might actually need to jump around, but there aren't any go-tos in this language, so I need to find other semantic ways of doing these things. So like this fobba call here, return fobba, because this fobba is a procedure within Fubu, this is just a jump. This would just jump down to here. So I think that's it for this example of procedures and procedure variables. I already talked about how this was last time, but stream broke, so how the ordering matters. These two aren't the same. These two lines aren't the same. Let's see. Yeah, I think that's all I need to talk about with this example. Procedures, there can be variables of procedures. That is the main takeaway. Well, that, and there can be procedures declared within procedures. And which example? Yeah, I'll just Oh, I forgot I wrote anything. I will quickly show this mutex. This is even more not done. I should specify. Specifically down here on this line. This was before, and I'm still not even sure I'm doing this, about having operator and then putting unary star. I'm still not even sure about that syntax just yet. But I'm definitely not sure about the comment up there. So this mutex is certainly certainly not going to be the mutex that appears in the standard library, because I will have a mutex type in the standard library. It's probably not going to be like this exactly. The interface is going to be pretty much the same, but probably I might rename things. Basically, this mutex type specifically is about some piece of data. That's why we have this variable up here. Now remember, this is the last time when I showed the type composition, I was using the number sign syntax, and there's the number sign syntax. I still have to think about whether it's needed for if you only have one thing, but that's minutia at the current time, for this example at least. So with this mutex, essentially, I would declare a variable that has this type. Like, say I have, I don't know, a real vector 3. Let's say it's position for something, I don't know. But instead of just being a real vector 3, I actually make it a real vector 3 mutex. So now, this variable, position, has, and this is how this mutex type differs, is that this mutex type is about this data, and so I can unlock this data specifically. Like if I had position, I try lock, and I currently have it listed with PID, because of course that's what you'd call it in Linux, with process ID. I'm not quite sure about that though. I might change that. But say we're 0, which if we only have one thread currently, then of course we are. Or no, not 0. So I'm using 0 up here for that is one thing actually. Wait one moment. Okay. That is one thing about this type, is that I'm using 0 to be nothing, which I've still got to think about, because that kind of, yeah. So I have this, let's say 1 currently. So I try the lock. I would get the lock at this point, because nothing else is trying to get it. Then of course I would have my critical section. If you know about parallel programming, about critical sections, of course, specifically this mutex type might be based on another type, a base lock that doesn't deal with, of course, specific variables, but actually just deals with locking and unlocking. And then I would go, position dot unlock. and then the critical section would be over. And then, you know, at this point it is, you know, ill-advised to use well, technically use start position. Because since this data that it's protecting is, of course, the data here in the actual type, in this variable of mutex type, composes that type. So that is this is the type of the data that it holds. And to get it back, or to, you know, just access it in general, do start position. And so now this will return the data, but of course it would only be advised to do this while you have the lock. I might put like debug stuff to say that it doesn't have the lock or something in the actual one, but for right now, assuming this simple mutex type, then I would say here's my position, and then, you know, maybe I have another real vector 3 p, and then I just assign that, and, you know, that might be something that you need for, I mean, you definitely need to lock this if multiple threads are going to be accessing the data within here and editing it. But you could do that, or you could also edit. I'll put this here now, but I haven't yet explained how this works, and neither is this unary operator up here actually formatted correctly to work for this, but technically I could also do it the other way around. But I had a become statement for this, but I'm thinking of just having become like up here. It used to be instead of the return here. Instead of the return, you'd have become, but I don't know. I might have it up here now and just have whatever return is the become. The become essentially, you know, if it needs to return a pointer to the thing, it will return a pointer to the thing, but you know, with something like this so small, it will literally just be like, yeah, instead of start position here, it's just going to be the position data, position.data, although you can't get to position.data right now. Because this is a objects. If you have a constructor, okay, I'm just going to explain this really simply right now. If you have a constructor, the type is a pure object, which means you can't access its data members. You can only access through its interface. Its procedures here, member procedures. And that's why here, since it is a data member, the data, I would use become. I'm still not sure on the become, but anyway, I would have this become unary star that would basically, because of my constant expression collapsing, this would collapse at compile time from star position to b position dot data, even though you can't access that in the actual Y source. In the intermediary, it would work. Wait one moment. Okay. So yeah, in the bytecode, and in the actual compilation, the start position would be swapped out for positions data member. But here in the source, you can't use it. And this is basically with become. When I was designing become, it was basically, if you know C++, you know that there are pointers and there are references, which I find to be quite ridiculous. So instead of having references in my language, I just have this become statement because I have constant expression collapsing, so I can just collapse start position. I don't have to do any fancy facading and be like, oh, this isn't a pointer. Like references are. It's just a return value. So I don't have to like have reference variables, which are just ridiculous in my eyes. Yeah. So that's a little bit more of an example, at least somewhat. Syntax-wise, things here to note that might change. This parallel keyword, I'm still not sure. Become, that might go there, might not. I don't know. Mutex even. I'm thinking about just making it CTOR, for constructor. So I'm not even sure about that, but I'll have to see. I mean, this right here, this mutex is the type because this is a this is wrong, actually, now that I look at this. Ooh, I didn't notice I was... This should also have false. Or not false. No. F. since this has 3 member variables, I assign them in this struct, this struct literal, which I can use here inside the pure object because it's inside of it. Outside of this, just like trying to do position.data, you wouldn't be able to assign mutex like this because it's a pure object. But I think that's everything that I needed to go over for the last time when the stream cut out, and for this time when I finished that and went over this mutex type, and technically went over this become, I say semantics because exactly where the exact syntax I'm not sure of, but the semantics are there, at least somewhat. At least the constant expression collapsing, just put the pointer to this down here, and then perhaps that might also collapse to being, the pointer might collapse to being just a this dot data. Well, actually, if you know anything about assembly, everything's pointers. So it really saying it's not a pointer is kind of but whether it's a variable or pointer from the C style point of view is what I'm talking about. Yeah, it looks like everything is. Oh yeah, I have false here. That's why I did that before. Yeah, like I said, this is old syntax. I need to really update this. Because, of course, like, I went with T and F for the constants, for Boolean constants, because, truth tables. But also they're capital letters, and that fits the syntax of snake case. And then constants being, or at least constant variables being in all caps. Which I'm kind of loosely in between with my abstract concrete kind of syntax naming scheme, but that's something that I'll go through at another time, I'd say. Yeah. If it has a constructor, it's a pure object. Simple example of mutex and become semantics. Those are the takeaways, and the takeaway here is the food I'm gonna get. No, that's it. That should be it for this example, the last example, and I think I'll probably just go into another example the next time and be off for now. So unless hello. Yeah, this is Maestron. This is some old syntax technically, but this is the Y programming language that I've been working on. I have stuff on my channel, Twitch and YouTube. Started to put up stuff about this. Like, specifically, this is a vector, like a normal vector, like you do in vector algebra. And then I have, 3 elements, and they're all real numbers. And this uses, vector extensions, so you don't have to, do any type of shenanigans. That's just one thing. I would recommend looking at the other stuff that I have up on this. I'll be collaborating together this stream with the last stream that cut out, and putting that up as that'll be the second video. I put the introduction up as the first video, and I don't think I have any other videos up there. But yeah, well, I guess paradigm-wise, I should say. I mean, it kind of fits through all paradigms, so it's not really something that I kind of hate talking about paradigms anyway. But I can't give a really great simple description yet, except for the main features being portability, explicitness, efficiency, and this type system that I've made. But yeah, I am actually going to end there. So thanks for coming in, and I would encourage you to look more into my language. Because there are some great features, at least I think, in here. But I will be off then, so I will be back probably, I don't know, Thursday. So, farewell.